if you've just got this concrete, second you put it in tension, it snaps. What you really need is something in there to withstand the tensile forces. The best one is steel. First up, the easy one, reinforced concrete. You've all seen that steel mesh on building sites. Laid out, and then they pour the concrete over the steel mesh. A few key points on that. The steel is giving tensile strength. So now the composite steel reinforced concrete is strong, not as weak, less weak. Steel reinforced concrete is less weak in tension, not as weak as normal concrete. Still strong in compression. That's why we add steel to concrete, to give it some tensile strength. So reinforced concrete. While I think about it, we talk about failure of concrete and concrete cancer, it's called, spalling. I need a minimum 50 millimetres of concrete cover over the steel. The concrete is porous. That structure there is full of pores. Water can track through it and leak through it. Air can track through it and leak through it. If there's not 50 millimetres, let's put another bit up here, the oxygen gets to the steel. Oxygen makes an iron oxide. That iron oxide is a ceramic and it swells. That swelling pushes on the concrete surface. When that's swollen up enough, it literally spalls. Technical word for blowing something out from the inside. It spalls out a layer of concrete around the reinforcing. And you've all seen that. Go and have a look around your high school. I'm sure you'll see multiple examples of concrete cancer where you can see the steel reinforcing exposed. That's what caused it. You will notice it is not 50 millimetres deep below the concrete surface. That's why it has failed. So, reinforcing, that's steel reinforced concrete. While I'm talking reinforcing, just simple plain reinforcing, the other one is steel fibre reinforcing. The other way they can reinforce concrete with steel is they get steel fibres about the size of a needle, about that long, bent at both ends. And they have bags and bags and bags of them. Just imagine throwing around about 100 kilograms or 600 kilograms or 1,000 kilograms of needles into a concrete mixer. But the needles physically have a lock on both ends. When you batch them up, the needles, they physically get blended into the concrete and they're in all three directions. So you get three-directional strength from concrete needles. It's called steel fibre reinforced concrete. And if you want to see an example, have a look at the next set of steps in a railway station you climb up. You will see on the surface there is all these steel fibres. They've got to be stainless steel because of the fact they're exposed to the surface. But you will see all the steel fibres exposed on the surface of the railway steps. Probably about 15 or 20 stations I've been in. I've seen the steel fibre reinforced concrete there. Either that, just Google, and you'll see a picture come straight up. So that's reinforced concrete.